Okay, cool. Hey everyone, thanks for joining in on a beautiful Tuesday morning. We have Trevor Clarke, co-founder and VP of product at Amberdata with us, who is taking this workshop. You're not here to listen to me, you're here to listen to Trevor, so I'd let Trevor take over. Over to you.
All right. Thanks a lot. Yeah, like you said, I'm Trevor Clarke. I've been building blockchain things for almost 3 years now. And so what I'm going to present today is one of the awesome things that we do as a company. I personally believe blockchain is a great way to accomplish some very specific tasks. So today I'd like to introduce 3 practical examples of what you can do with Chainlink and Amberdata. First, we're going to go through a little bit of what we do, and then we're going to look at how you can use some of those data sets. If you're joining us online right now, awesome. If you're watching later in the future, hopefully this is a helpful resource for you. So let's get started. So I want to address 3 things today. First one is, how can I access off-chain data in my blockchain or in Ethereum? The second one, what is Amberdata and why should I care? And the third one, what is an Oracle and why is everyone talking about Chainlink? So for the first one, we're going to be focusing on Ethereum, but obviously for Oracle networks, this actually can work for many blockchains, especially if they support smart contracts. Chainlink is currently set up with Ethereum, but I would assume that in the future, it actually doesn't need to be bound to Ethereum. So some of the concepts that we're going to go through today, you'll notice actually probably apply to multiple blockchains. And for Amberdata, we focus on multiple blockchains. So what is Amberdata? We are your go-to source for blockchain and cryptocurrency market data. If you can see the diagram here, there's actually a couple things that we do, and that's for a very specific reason. We have blockchain data, which means we index all of Ethereum and other blockchains, everything from blocks and transactions to specific things like token transfers or smart contract events or human readable logs and interactions. And that's done on purpose so that you can actually use the blockchain in an application in production. So if you wanted to look at something in the past, it's actually pretty difficult to get that data from the blockchain. You need to sync your node. You need to go get a lot of data and then aggregate it before you can start using it. And that can be expensive sometimes. So what we do is provide that as a service. And then second to that, we have market data, which is a bunch of exchange data that we've collected and then supplement into that blockchain data. So that means you actually have the full context of the economics of blockchain right at your fingertips. This is something that you can supplement your application as well. If you wanted to, say, get your entire portfolio using your addresses, it would return a bunch of balances and token balances and even their traded market value if that token or currency is traded. So a few key things to point out, and if you're interested to learn more, go to Amberdata.io. But the key things here are, we have cryptocurrency market data. A lot of folks use the token transfers, which is something that the blockchain doesn't provide out of box. Contract events, token price, tickers, OHLCV, which is something like candles if you're familiar with that. VWAP and TWAP, which we'll be actually using today. And then order books, order snapshots, and WebSockets. All right, so we're going to do 3 different tasks in Solidity. The first one we're going to do is a price reference contract. So we're going to use Chainlink to get the price from Amberdata, and we'll go through that flow. The second one will be a GasPrice Oracle. Many times when you're building a smart contract, you want to understand what the market is saying the gas price is, and that's something that's kind of difficult if you're doing operations within a smart contract. So this is a way to kind of have a heartbeat of what is the current gas situation, what can I expect, and kind of help um, give that to a smart contract. Last one is, this is just a practical example that I was using and I thought would be helpful too. If you want multiple return values, I don't think it's possible yet still with Chainlink. So I built just a small example of how you could do that. Hopefully in the future, there's better methods, but this is my method. So we're going to go over to Chainlink and we're going to walk through those examples. Awesome. So we're going to go through kind of my setup for a minute here. Actually, I'm going to click back just to make sure. Yeah. The first couple things we're going to do here is look at some of the functions that are set up, what you should be using in your remix settings, and then we're going to do a full deep dive into how you can debug and test that connection to make sure everything is working correctly in your contract. And then at the end, I'll actually link you guys to all of the source code so you can see, you know, this is what I'm using, this is what I've tested, and maybe that's a good starting point for you, or just, you know, additional resources for you as you build these things. So I want to point out real quick, I have MetaMask installed. I also am pointed at the Ropsten network. This seems to be the primary network that Chainlink is using, so I've been kind of focusing test cases with Ropsten, but I think they also support Rinkeby and Kovan as well. So this is kind of a test account. The other thing that I have in here is link token. So every interaction from a smart contract to the Oracle needs to have link token. So there is actually a faucet. I think it's Rinkeby dot something. I have a link later that we can look at. This is the link token that I got from that Ropsten link faucet. And this is critical. This is exactly some test tokens that we need here. So if you don't have any yet, make sure you do before you start testing. The other thing here, I have Solidity loaded up in Remix. There are a few other options. I am also using 4.24 today. I have another set of contracts that are supported for 5+. So those ones I'll be linking to, but this is what I have available in Remix today. I'm going to go ahead and compile this price aggregator. Now, in here, I have injected Web3 provider. You'll notice that it pulled in the Ropsten network and my test account address. You don't really need to worry too much about these values here. So we're going to go on to this one. This is where you can choose which contract you're going to deploy. And it's loaded up the one that I've coded here. You'll notice contract Amberdata price basic is Chainlink client is ownable. Those are both pulled in from the top. I've loaded in the basics that Chainlink provides from their repositories all in one file so that it actually helps Remix compile faster. This isn't necessary if you're going to build your contract, say with Truffle. You can put that in a different file or have multiple files and it'll do just fine. So for this one, I want to point out a few critical things. The first one being, you need to specify the link token. This needs to be provided whenever you're making a request. So it's very important to have that actual definition of the link token available. And then here it's just set up as a standardized unit, but the link token is actually the address of the link token that we'll be using in Ropsten. So then there's actually two things. The first one is going to be request token price. So there's this common flow with Chainlink. Oracle contract. Oracle contract then dispatches an event, which gets triggered to some nodes, and those nodes make public requests to public data. So that public data, when it comes back to that Oracle node. The node then can send a request to your smart contract with the result of the data. It looks like Thomas linked to robson.chainlink. I think I have that robson.chainlink link. Perfect. So this is the faucet that I was talking about. Thank you. So if you're short on link token in Robson, go here. And that'll be a good resource for you. So yeah, going back to the flow, request token price. This is where my contract is going to ask the Oracle contract, hey, can I get the recent price for X? And we're going to pass in a token address for it to get the price of. We're going to be using an Ethereum token price, but we could also build a function that's maybe something like string ETH or 0x or something like that. So there's a couple different ways that you can get that price data, but this is the one that I find most interesting because we're all in the token address ecosystem anyway. So a couple key methods. We need to build the Chainlink request. That's going to be a string and then a callback. So we're going to submit a job ID, and I'll talk about that in a second. And we're going to submit that callback, which is when that result comes back from the node. This is how the Oracle contract can submit the result. So in here, I'm doing market token prices and then concatenating the token address with latest. In Amberdata, we actually have historical price. So you could specify query parameters for other start date, end dates in the past. But this, we're just going to use token price. And if you want, there's actually some documentation. If you go to docs.amberdata.io, we're going to be taking a look at current token price. So you can actually see examples of, here's the result of the data that's coming back. We're going to be looking at price USD. So we want the value price USD. We could also get other things in here, really up to you. But if you want to look at what I'm looking at, go to docs.amberdata.io, reference, and then click on get current token price. So we also need to point into that data model. We have the endpoint, but when the data comes back, we want to say, go grab one value. When Chainlink does its request, it gets the whole data set, but it only submits the data, the specific data pieces that you specify. So in here, I'm saying payload 0, and that's kind of a magic thing right there. And then I'm doing dot price USD. So what does the 0 mean? I specifically chose that because the result is actually an array. There are many different ways you can get data. We've standardized this response into an array. Sometimes you can pass in multiple addresses, for example, and you want to get multiple prices back. In this case, we only specified one, so we got one price. And so the array, we want to look at the first item and get that price USD. So that's the reason for this 0 here. Lastly, we want to multiply by 100 in Solidity, how it handles numbers. We just want to understand that integer without the floated values. So we're going to multiply this by 100 and hopefully get something that makes sense. And then lastly, we just execute the request to Chainlink with all the specifics that we've put in there. And then the next one is actually really easy. So the callback, fulfill token price, really we're just looking for two things here. We get the request ID to make sure that it's the same thing that we actually asked for, which is something that is made from this previous request. And then second is the price. So I've specified a uint 256. This is just the most generic value I could say here. And then we're storing it in a single value here. So get current token price, the current token price being that uint 256. And we're going to assign it that value every time fulfill token price is called. So let's do that. I'm gonna deploy a new contract. MetaMask is pulling up if you can't see that. So it's going to deploy that contract. And while we're doing that, I already have one that's deployed. This is a way that we can just keep talking through here, but I'm going to keep going through the steps when it's finalized so you can actually see like what the real process is. It was actually much quicker than I was expecting. Cool. So what I did was copy the address of the deployed contract. So we're going to go over here, find some link token, and send to our contract. This is critical. Again, if you don't send link token to your contract, there's no way for your contract to actually call the Oracle contract and expect something in return. So failed to send link token. I'm going to try again. Maybe the contract wasn't quite ready yet.
MetaMask is a little buggy sometimes that you have to click on the like one of the transaction fee buttons to update the gas limit.
Yes, let me do that. Let's see what our we'll just go crazy high right now. See if that works, and we'll do that for the other one. They both look pretty high. Let's try that again. So that should work, hopefully. All right. So this is a good time where I'm going to talk about job IDs. So there's a lot of documentation in Chainlink. Awesome, the token sent. If you haven't been here yet, you should. There's a lot of references here for all the other services that Chainlink has. So what we're going to be looking at today is the Amberdata Chainlink testnet, which is using Ropsten. You'll notice there's a few other options here. So Ropsten, Faucet is probably the link there. Things that we're going to be using, the Oracle address, uint 256. So that's what we want to grab here. I'm going to copy that. And I'm also going to copy this one. So we're going to go back here and open up the contract. Remix has this really nice way of bootstrapping your methods. So we provide 3 variables here, and it gives us 3 inputs. I'm going to put the Oracle contract address there. Bytes 32, we're going to have to do something special. So I'm going to paste this as a placeholder for now, and we're going to come back to it. Token address. So we actually built a really cool project at Amberdata called WB3IO. It's basically a URL shortener that's pre-generated by all the blockchain data. So if I want to get the price of something, I can just simply say like link or something, and it's going to pull up a ranked ERC20s or other data from the blockchain. So I can grab that token address and then go back over here to Remix and paste that into the token address field. So that'll be the address of link token. We're going to get the current price of link token through this request. So like I mentioned with the job ID, I specified it as bytes 32. So we actually need to convert that value. And we're going to be using something called web3.ut2hex. So this is the value I'm going to be pasting in there. You can then see it's got a 0x, which is the actual hex value of this string. So we're going to paste that in there, and then we should be good to go. So we can hit transact. You might not be able to see my MetaMask, I'm not sure. I'm going to throw that on fast for gas, and we should see that go pretty quick. So if I were to get current token price now, it gives me 0, and that makes sense, right? Like we haven't called an Oracle contract, and no Oracle contract has called us. They probably don't know that this contract even exists yet. But once I do the transaction with the request token price, it's going to submit that transaction out and have that data fulfilled at some point in time. So now that we've submitted that transaction, now it's a good time to show you, here's an explorer that shows all of the job IDs for requests and some of their payloads and how they're getting fulfilled. So you'll notice just now this run ID for the job ID that I turned into bytes 32 is there. Looks like it already got the value, but now it's waiting and submitting another ETH transaction back to my contract. So that was pretty quick. We actually, in the time that I was talking, it was already most of the way done there. But this Explorer is awesome. You can find your job ID, any execution that matches the other job IDs here. So any of these is something that you can use to look up other actions that are being triggered by your contracts. So I'm just gonna hope that that finished in the next minute or so. We can hit, yeah, no token price just yet. I do want to move a little bit quicker, so I'm going to go to the next couple contracts and we can look at them. I'm going to look at the GasPrice Oracle. Yeah.
This is a good spot for me to say anyway. For the job ID, you should just be able to throw a 0x in front of the friendly string job ID instead of having to specifically convert it to hex.
Yeah, I was doing that last night and I was having issues.
Okay.
Do you see this?
Oh, okay, yeah.
It's with the new remix had an issue with that. So
yeah,
went ahead and did
would
it.
Just right pad those zeros and
yep,
it would just carry on. But yeah, okay. Well,
so anyway, that's my workaround, and you guys got to see it.
Yeah.
Yeah, if you have any other ways of accomplishing that, awesome. I think this is probably just a short-term fix.
Yeah, this is just remix specifically because old remix would right pad those zeros to fill in the rest of the 32 bytes.
Yes. Yeah, there was a question. Can you show how you resolve job ID issue? Absolutely. So I don't have this in notes anywhere, unfortunately. This is just something that came up recently. Since I provided the injected Web3, I get access to Web3 down here. And the method is 2hex. That's something that just works magically. But you can paste the ID of your job in there and it'll just turn it into a nice string. We can do that again if you want to. I mean, take another job ID, throw that in there. So those are the two main ones I was using anyway. Yeah. All right, we should have a price at this point in time. So 271, which is actually 2.71 USD. So there we go. The price worked. Cool. So moving on to the next one, we're going to talk about the GasPrice Oracle. This one is interesting as well. So instead of looking at an array value, I just want to look at an object value. At this point, we're going to look at payload average gas price from our predictions endpoint. So if we go back to the documentation, we can look down at transactions, get gas predictions. So payload average gas price. That's the value that we're going to be retrieving here. But there's also another thing I wanted to point out if you're curious. There's a way to get different percentiles. So maybe your contract wants to stay one step ahead to beat the traffic maybe. The other endpoint for percentiles kind of gives you a lot of values to choose from if you want. But going back here, we're going to use payload average gas price from the gas predictions endpoint. Just exactly like you would think. We're going to send the Oracle contract our gas predictions endpoint, and we're going to tell it where in the object to get the value. So I'm going to go ahead and go back over here, compile Amberdata gas price contract, and make sure it's the right one and deploy it. And we're also going to deploy the next one. So this one I'm going to talk about, and then we'll test both of them at the same time. This is for multiple return values. So I had to do something a little bit interesting here. First of all, you'll notice there's a mapping. So in this example, I'm looking at Amberdata security audits, which basically means we run automated security audits for all of the contracts on Ethereum. That means we check, how many issues we find, or maybe informational things, or different standards, security standards, if they've flagged anything, and keep track of that with a letter grade score plus a total amount of issues. So you'll see the current or the security grades and the totals. Those are both mappings based off of the address of the contract, and then it stores the value that's returned. The last thing that we keep track of here is the receipts. So this is a way that we can have multiple return values from the Oracle contract, but keep track of them with the same receipt, such that we don't lose track of at what point in time that was requested, and then we can store those values into these other mappings. So what I did here was create two different requests. So I do one method here, request security grade, and we pass in two job IDs, one for the grade and one for the total. And that's specifically because we're going to get a string. So we need the bytes 32 value. And we also need the uint 256 value for the total, which is an integer. And then we just pass in the hash or the address of the contract we want to get the security audit grade for. So again, we're doing some string concatenation, but you can see we're looking at the contract audit here. And then we're also looking for the score name, which will be like an A, B, C, D, something like that. And score.total, which will be a value of 0 to 100, or something like that. We'll find out when we get the value there. I'm going to pause here a minute and pass some link token to the GasPrice Oracle. I'm going to paste the address in there. And hopefully this goes pretty quick. Awesome. And then once we have both of those, it's actually making both of those requests immediately after we've specified what's going on there. On the other side, on the callback side, we're getting a stringified grade, and we're storing that into the mapping using the contract hash. But we got the contract hash from the receipts. So that's kind of the magic here for multiple returns. Your receipt kind of keeps track of, or you can keep track of other ways of mapping if you store the receipts. So that's what I'm doing here. And then I'm removing the receipt once I've used it. I will get a receipt per request. So each one of these requests is keeping track of a receipt ID, or a request ID rather. So in the callback here, it's going to store my grade, and then it's going to store my total. And then I created a little helper method so that I can get the whole audit as a tuple. So this will give me from my address all of the security grade and total that work for that address. And then there's something special that I stole from the ENS, one of the older ENS contracts, which is string to bytes 32. if you want to use that in your contracts. Also, it's kind of helpful for some of these requests. That'll be in the example repo that I linked to at the end here. So yeah, something nice to have. So let's go ahead and deploy this one. Oops. Security audits, deploy. All right, and at this point, we should be able to ask for some GasPrice stuff. We want to get the Oracle contract. I'm going to keep doing this so you get the flow. We want the job ID. I forget what I put in here. We want the UINT 256 for the GasPrice. So I think it's the same one as before. So let's use, yeah, I think I might have it loaded up actually. Yeah, there we go. See if we can do, oh, we've got an issue. Nice. That's actually going to fail. I might have a bug in my contract code here. Let's come back to that one. We can try to debug that at the end. I want to show off the multiple returns. So we'll move towards that one. I'm going to send that one link token, and that one needs to have at least 2 link token because it's got 2 requests in it. But I'll put more just to be careful. Yeah. And while we're waiting for that, I'm going to look for request security grade. This one again, I'm going to go look for, let's say, 0x maybe. So 0x, we should look at console. Security grade is A. It's an older contract. It's got a integer overflow issue, looks like. So we'll take that address again, go back to remix. I'll put that in the hash field. So now we can fill out the rest of this. The Oracle contract we have here. So C99 in this case. And then we need to do the bytes 32 for both of those. So for the grade, we want that string or the bytes 32 in this case. So I'm going to load up the method again, and that's that one. And then the next one, I think I've got it in the history here. Yep. I'm going to pull both of those job IDs as bytes 32. Let's see if those tokens send. Cool. So likely the tokens are ready, so we can make our contract requests. All right. So I sent that off. So now we actually should have 2 different job IDs happening at the same time. So I've tried to load both of those back up so we can, cool. So we have one, this one right here that was just submitted. And then this other one, which works for, I think this is our bytes 32. Nope. Let me paste that one. Yeah, that should be the right one though. That one's missing. Well, let's double check this one. Might just be processing a little slow. Actually, let me make sure that this is submitting correctly. Yeah, it looks like it did. So just have to be patient. We should also make sure that the request parameters make sense. So let's do contracts hash audit and go to you can also do this as well. Whenever you're creating different requests, you can kind of look at pretty much any endpoint. I mean, for the Amberdata stuff, you can actually request other blockchain data, for example. It's not restricted to just market data. So in this case, contract hash audit. So that should be right. Cool. So we'll just wait for that to confirm, and then we'll likely get the grade. If we passed in 0x hash now, it probably won't return anything meaningful, which makes sense because it's not confirmed yet. I lost that value, so I'm going to grab it again. Cool. Oh, it actually finished. So we got the letter A, and we got 2 for 2 issues. And that makes sense because we just pointed out is integer overflow 2. It's a total of 2. You could go look at this if you're curious later, but there's the actual audit. There you have it. You actually see the 2 values. The first one is the bytes 32. And if you look at the end, it's just a padded letter A. And the second value there is a uint 256 of 2. Cool.
Another easy way to use the Explorer is just search for your requesting contract address. And then you can see all of the jobs. So your other job ID that you used was for the raw bytes instead of the bytes 32 job.
Yep. Makes sense. There you go. That's sweet. I didn't know that. Thank you, Thomas. So there you go. You can see that it did make 2 requests. Cool. So at this point, we went through this process. I want to make sure we kind of do a recap, and then there's actually a question here. What values did you pick for job ID grade and job ID total? So let me go back to the contract real quick. It shows you bytes 32 in the input. That's just easier for building the request, but I actually used the values from the callback function. So the way that I'm going to store it is uint 256 in the mapping and bytes 32, or sorry, bytes 32 at the top here, and uint 256. We use the job ID for bytes 32, which will be this one, and then uint 256, which is this one. So that's where I got those values, and then we did the conversion using web3.2hex. Cool. So going back here, yeah, we went through there and actually showed off the Amberdata dashboards, which are pretty neat if you want to kind of explore different contract stuff. I pointed out this string to bytes 32. The other one is concat, which is helpful. At this point, I want to make sure you see this. I'll have a QR code in a minute that you can scan, so you can grab that. I'll also put the link in the chat real quick here. So this example repo has exactly what I talked about today, where you get the price basic, security audit, and I think the basic contract here has the gas Oracle in it. But there's actually a few other examples here. One in particular to look at is the link balance. If you want to double check that your contract that you've deployed has enough link token to make those requests. Yep. Cool. So just finishing up here, QR code is tons of resources. There's also, I think we've posted it in the Discord, a huge article about everything that I've talked about, how to do that flow of requesting and debugging and all that stuff. And then if you're interested, there's a coupon here, link-webinar, to sign up for our Amberdata API service. This should give you a free month of Amberdata if you want, and just go ahead and explore the APIs. That'll give you market data for quite a few blockchains and lots of cryptocurrency market data. Cool. And then I think the next slides are in case Remix wasn't working, we could go through code from here, but that's it. So thanks, everybody.
Thanks, Trevor.
Does anyone have any questions for Trevor? Trevor is also on Discord, so you can find him on the Amberdata channel on the Chainlink Discord.
Yes, please do. If you have questions for the next weeks, mention @T_Clarke, and I'm also in the Amberdata channel. So look in there. I'll be kind of watching conversations as they come in.
Hey guys, can you hear me? This is Dan with Chainlink.
Hey.
Hey, yeah, sorry. I was struggling to unmute my phone there at the end. I just wanted to just let everyone know that I was here and say thank you, Trevor, for that amazing workshop. I really appreciated your just insights into the industry and hearing your workshop and going through it with you and everything. It was really cool, and this is going to be awesome to put up as a video, and our community is going to absolutely love it. So thank you so much for your participation, and I hope that we see you around in our Discord channels even after the hackathon, because we love having you in our community.
Awesome. Thanks a lot, Dan.
Yep. Thank you.